Practical exercise 1. Introduction of logic gates. In part 1, we use different types of ICs and find the different gates to each IC. They all have the same location of output and inputs, so we only have to build the circuit once. The circuit can be seen here below, where the green arrows show where the input is and the red arrows show where the output is. In part 2, we have to do a minor adjustments to the circuit that we used in part 1 and find the gate types of two ICs, 7402 and 7404. The pictures of the IC below shows the function of each IC. In part 3, we are going to show that different types of circuits with different gate types can show the same results by changing the circuit. On the bottom is two images. The left one is a picture that navigates us on how the different type of ICs work, and on the right side are the three circuits that we built for each IC. Practical exercise 2. Addition, subtraction and memory. Part 1. In part 1 we will be doing a half adder and a half subtractor. You can see that on the slide there's two pictures on the bottom. The left one is the second circuit we will be building, and on the right side there's a first. The half adder circuit takes in two inputs A and B and returns two outputs, carry and sum. From the truth table, we can derive the following Boolean functions for the sum and carry using sum of product method. In simple terms, the half adder circuit adds two single bit binary numbers. Here we can see the function. Now let's look at the half subtractor. Similarly to the half adder circuit, the half subtractor has two inputs and two outputs. However, the outputs in a half subtractor circuit are different. D and borrow, B out. The Boolean function for the half subtractor are divided with the same method as the half adder. Here you can see the function. The SLATs is a sequential circuit, meaning that their output not only depends on the latest input, but also on early inputs. The SLATs consists of two NOR gates and takes two inputs and returns two outputs. The name RSLATs is based on the input variables, which are called set and reset. The inputs are Q and Q complement. And here are our results from the SLATs. In the third part of this experiment, we take a look at JK flip-flop circuit. The difference between JK flip-flop and SR latch is that JK flip-flop is much more complicated and it doesn't rely on which button was pushed on previously. The first we did was putting both J and K to ground. And what you can see is that it toggles between Q complemented and Q. The next thing we did was we put J to ground and K to VCC, and the circuit showed that we had a reset state. Next we put J to ground and K to VCC, and the results of that was that only thing that happened was that one light turned on, so it's a set state. The last one we put both to ground and one light turned on, so that was hold state.